Hey everyone, this is Mr. Nam, and today I'm going to be going over my 8th grade science lesson for Thursday, October 8th. I'm going to start going over the lesson and then I'll dive into the asynchronous assignment because it is a little different than what we've done before. So your bell ringer for today, guys, was just you're going to illustrate it. And the planets and the sun are different sizes. Use different shapes to show the size of the sun and earth compared to one another. Okay, so go ahead and do that in your digital notebook. Your learning target for today, guys, is you're going to be able to create a diagram that shows the correct scale of the solar system. Every planet is different size. We're not all the same equal size. So today we're going to talk about how can we accurately show the correct scale of each planet. Your vocab word for today, guys, your first one is orbital plane. That is a flat surface surrounding the sun and extending to the edge of the solar system that a body orbits. As you can see with this image on the bottom right of your screen, you have the sun's orbital plane, which is that slanted oval shape of the white line, and you can see the different orbital planes of each planet. The second word is orbital period. And this is the time it takes for a planet to make a complete revolution around the sun. For example, Earth's orbital period is 365 days, right? But if you look at other planets, Mars's orbital period is 687 days. Saturn is 29.5 years. Okay, so the farther a planet is from the sun, the longer its orbital period is. Your third vocab word, and this is the most important one, guys, is astronomical unit, or AU. So this is the average distance between the Earth and the sun. And this is a unit of measurement often used for determining the distance in the solar system. So one astronomical unit is the distance from Earth to the sun. Any planets that are closer to the sun than Earth, Mercury and Venus, its AU is less than 1. Any planet farther than Earth from the sun has an AU of greater than 1. Okay, and that's what we use to kind of measure relative distance. So the essential question today is, how big is our solar system? Okay. In your digital notebook, what I wanted you to do is write down what you notice about the image on the left. What do you notice about the different orbital planes? Each color represents a different planet, and then you have the suns. What do you notice that is different? Okay. And then you were in breakout groups, but you probably are doing this on your own if you're watching this video. So in your notebook, I want you to answer which planet gives you the most frequent birthday and why. Okay, and why? All right, guys, rapid idea. So your rapid idea today is our solar system is one of many that make up the Milky Way galaxy. So there's a lot of solar systems in the Milky Way galaxy. And the gravitational force is from the center of the Milky Way, which causes stars and stellar systems to orbit around the center of the galaxy. Think about the center of the Milky Way as a big, big, big star, okay, and a big sun that has a really strong gravitational pull. However, the gravitational force of the sun causes the planets and other bodies to orbit around it, and that keeps our specific solar system in place. As you can see, the sun is this tiny, small speck in this large Milky Way system. Okay. So your assignment for today, guys, is in Google Classroom, and it's called The Size and Scale of the Solar System. I'm going to pull it up right here. So on this first slide, what you're going to do is you're going to click on this link, and it's going to open up this website. Okay, I'm going to click and refresh it so that we're all on the same page. Once you have gone to this link, as you can see, this will load. What you're going to do first is when you get to the scale by the sun, use the menu at the bottom to show the distance in AU. Okay, so what I mean by that is when this website loads, give me a second, it's loading, almost there, we can do it, yes we can, I believe in you, awesome, okay. I'm going to scroll back all the way back to the sun, whoopsies, oh, what's going on, let's go back to the sun, okay. As you can see, when it's at the sun, okay, the first thing you need to do at the bottom here is you need to change this to AU. Okay, that's astronomical units. Okay, there's 3 different ways, as you can see here, to scroll to each planet. You can scroll to the right at your own pace, like this. You can click on the bottom right. There's a speed of light bottom, which then tells you how fast light travels from the sun to different planets. Make sure you change that to AU. And then there's also, you can click on planets specifically at the top, and then it'll automatically take you to that planet. Okay, so let's go back to the sun so we can start. When you're at the sun, what you're going to do then is on the next slide, okay, slide 2, what you're going to do is record in this table the distance from the sun in astronomical units. So if I go back to the website, let's say I click on Mercury. As you can see here, it tells you AU. So Mercury is 0.4 astronomical units. So I'm going to go here and I'm going to type 0.4 AU, just like that. Okay, I might have to tweak the text a little bit, but that's what I'm going to type. Then you're going to go to Venus and do the same thing. If you do it correctly, Earth should be 1 astronomical unit, right? Because 1 astronomical unit is the distance of Earth to the Sun. And that's why Mercury and Venus have an AU of less than 1, and any planet past Earth has an AU of greater than 1. Once you've done all that, okay, and you filled in that table, you're then going to write a racer's response here and answer, is the distance from the Sun the same for each planet? Is the distance from the Sun the same for each planet? And be sure to include evidence, and you can use more than one piece of data from your table. Okay. Like always, guys, if you have any questions, let me know. If not, this assignment is due at midnight tonight, and I'll see you folks tomorrow for Friday's lesson.